So the question becomes, how do we find probabilities if the events are not disjoint, i.e. if there's an overlap? And the answer is you use this general addition rule. So you take the probability of one event plus the probability of the other one, and then you subtract away the overlap. Let me see if I can get you to understand what I mean. So here I have a 52 card deck, and you're going to draw a single card. Let E equal drawing a heart, and F is drawing a face card. Illustrate the sample space using the Venn diagram. So over here I have all the hearts in this ring, right? And then over in this ring I have all the face cards. So you can see ace of hearts, 2 of hearts, 3 of hearts, 4 of hearts, 5 of, and so on. And then in here I have the king of hearts, queen of hearts, and jack of hearts. We'll talk about that in a second. And then over here, king, queen, jack of diamonds, king, queen, jack of spades, king, queen, jack of clubs. Now, what's going on with these three? Well, those three cards, the king of hearts, the queen of hearts, the jack of hearts, they're hearts, so they belong in the left ring. But they're face cards too, so they belong in the right ring. In other words, they're in the overlap, right? The intersection of the two rings. And then all the rest of the cards are out here. All the, ace of clubs and queen of, or not queen, ace of clubs, 7 of spades, etc. All right, now, what's the probability of drawing a heart? Well, you can see there's 13 cards total in that ring, right? In a deck of cards, there's 13 hearts. So it's 13 out of 52. What about a face card? Well, there's 3 faces for each suit. There's 4 suits, so that's 12 total. So there's 12 face cards total between these 3 and these 9. So that's 12. Now, what about the probability of the card being both a heart and a face? Well, there's 3 of them. There's the king of hearts, the queen of hearts, the jack of hearts. So that gives you a 3 out of 52 chance. What is the probability of E or F? So that's a heart or a face card. So you could draw a heart, you could draw a face card, or you could draw both. So you can say, okay, well, I've got 13 hearts and I've got 12 face cards. And up until now, we just did that. We added them, right? That's what we did back here, right? You said, oh, craps, that's 6 plus 2, and I'm done, right? But that's because when you roll dice, you can't roll both 7 and 11 at the same time. But down here, you could pick a card that's both a heart and a face at the same time. So it's not fair just to add them up, because if you add 13's all this ring, 12's all this ring, but you've counted these 3 cards twice. You counted them in the 13 and you counted them in the 12. It's called double counting. Well, that's no good. So you subtract away one of those sets of 3. So you subtract away 3 out of 52, and that way you're only counting those 3 cards once. And that gets you a total of 22 out of 52. All right, so let's do it again. What about here with the contingency table, which should look familiar to you because we've done it before. And now I want to know the probability of female, the probability of AA, and etc. So I'm going to go back to my spreadsheet, and I've actually already done it, so bear with me here. I'm going to change my coloring just a little bit. So we did this one before. This one, and I didn't label it before, but I should have, so I'm going to label it now. So this was, ooh, I hate that color. Oh, let's make it purple. All right, so that was the probability of AGS or AS, and that was just we added up these 2 guys right here. Everything was grand. Okay, so we got a total of 1007, and honestly, I could have just done it like that. I could have done sum of, let's see, D4 to E4, and divided by the total, and boom, there we go, and I don't even need that. Okay, so I'm adding these 2 purple guys up, and I'm dividing by my grand total right there in the corner. All right, now they want the probability of female, and I'm going to make that blue. I know I made it the other color before, but I'm going to switch it now. Okay, so female is this whole row, right? So you'd say, okay, there's 4001 divided by the grand total of 6548. So there we go, right? So you take 4001, I said H3, cell H3 right there, divided by this total down here in cell H4. Diggity done. Now what about AA? Associate in arts. Not Alcoholics Anonymous. So what's the probability of an associate in arts? Okay, well, in that column, there's 1,194 students. So the probability that a student is going to be in Associates of Arts as their major is 1194 over 6548. Okay. Now, what's the problem with that? Well, the problem is that we've counted this green overlap. Yellow and blue make green. Get it? Oh, well, never mind. All right, so this column right here we counted, and this row right here we counted. But we've counted this green square twice because we counted it in the row and we counted it in the column. So for part C, they're just saying, hey, how much is that overlap? What's the probability of both AA and female? Well, that's the overlap. That's 665 divided by 6548. And I found it, with a little cell referencing action. Okay. And same with this one. I found this one with B4. That's 1194 divided by the total right there. Boom. Okay, so then the last part is that they want the probability of AA or female, right? Well, that's the probability of AA, 4001. That's this row. So you take row 3 and you take their total, right, 4001, plus this column, the AA column, right, which is 1194, but you have to take away the 665 because otherwise you've counted it twice. That's no fair. So you subtract 65. Now what I did was I said, well, we already found these probabilities. 4001 out of the total is right here in the blue, right? And then the 1194 is right here in the yellow. And they subtract away the green, and you'll have your grand total right there. So it's 0.69181 or so. And then I just put those right back in here. There we go. Right? So just catch that if it has an overlap like that, you're going to have to take it away. Fortunately for you, contingency tables are the easiest overlaps to see. They're where the column and the row intersect, right? Other problems, it can be tricky to find that overlap, but not on contingency tables. All right, let's start the complement rule. I don't know if I'll finish it, but we'll see how it goes. So complement doesn't mean, hey, you're a nice event. No, it's not that kind of complement. It's complement with an E in it, right? So the complement of an event is all the outcomes in the sample space that are not in event E. So that would be E complement. There are a couple different ways to abbreviate it just for the record. You can do E with a bar over it. It looks like this, E, like that. There's also E with a little prime after it. That tends to mean E complement. Or E with a little C after it, E complement. Okay, so if you're rolling a 10-sided die, it could be any sided die, it doesn't really matter about the 10. And event E is rolling an even number, then the complement is not rolling an even number, which of course would be rolling an odd number, right? So if you're not rolling an even, you're rolling an odd. All right, now what about selecting a person at random and that person has AB blood? If event E is having the AB blood, then E complement is not having AB blood, which means you have anything else. You could have O, you could have A, or you could have B. Remember, there's 4 main types, O, A, B, and AB. All right, what about children? Now this one gets a little interesting, so pay attention. If event E is you have both girls, right? So you have 2 kids, they're both girls. The complement means you do not have 2 girls, which means it could have been boy-boy, it could have been boy-girl, or it could have been girl-boy. So that means that the complement of having both girls is having at least 1 boy. If I could find, there it is. And that's not going to go away, my friends, right? So the complement of having both girls is having at least 1 boy. That's a hint. You're going to need that later on. All right. So let's get down here to the handy-dandy complement rule. So if an event E and its complement comprise a sample space, that means that their probabilities have to add up to 1. So if you want the probability of the complement, you just take the probability of the event from 1 and vice versa. All right. It looks more complicated than it actually is, believe it or not. I swear. I would not lie to you. All right, so what about the probability of a heart complement? Okay, so according to this rule, that's 1 minus the probability of a heart. But we know the probability of a heart is 13 out of 52 because there's 13 heart cards out of a deck, right? 52 card deck, which remember is 39 Oopsie. 39 out of 52. Now, where am I getting the 39 out of 52 from? Well, hold on. They've got to add up to 52 total. I mean, that's one way you can see it. You can do the whole LCD thing, make this 52 out of 52 and subtract. You can also go, okay, well, 13 and 39 have to make 52 total in order to get 1. That's another way to do it. Or you can just, have Excel help you out. I mean, you don't have to put this in your spreadsheet. That's no big deal. But you can just say, okay, 52 take away 13, that's 39. Oops. There you go. So it's 39 out of 52. All right, now what about the probability of not drawing a face card? Well, according to the rules, that's 1 minus the probability of a face card. Okay, well, there's 12 face cards total, so that'd be 40. Ooh, right? Not 38, 40, because they got to add up to 52, right? 12 face cards means there's 40 non-face cards, right? And I don't know what that is in a decimal, and I really don't care. You can find it if you want to. Now, what about our associate's degrees here? What's the probability that a randomly selected graduate is not getting a certificate? So that's the complement of a certificate, right? Not getting a certificate. So that's 1 minus the probability of certificate, which is 1 minus this guy right here, 0.2117. And if you want to find it with Excel, I guess I should really name these. This one was the fall enrollments one, the contingency table one. And over here, oops, not there, here was the graduates, right? Okay, so for the one that we're on, there, I'll put this in. So this was 5.2 example, which one was it? Example 9. There we go. So it was equal to, we want the probability of not certificate. That's equal to 1 minus this probability right there. Boom. Diggity done. Make it green. All right, then what's the next one? It's, oh goodness. Okay, so they want the probability that a randomly selected person is not getting a concentration or a skill set. Okay, so that's a little bit more complicated because you have to first find the probability of getting a concentration or a skill set. And that's an or you're going to have to add them up, right? So you got to add those two up. So 2117 and 0483, and then take it away from 1. So let's do it. So this is, hold on one sec. There we go. So it's equal to 1 minus the probability of, okay, let me put it this way. Okay, so the probability of con or skill set, concentration or skill set, is equal to the sum of those two things. So concentration's right here, comma, skill sets right here. Okay, so not getting one of those is equal to 1 minus what we just found, right? And I think I did this wrong actually when I typed it. Yes, I did, right? So I said, oh no, I guess I didn't. Con or skill set right there. So then I added them up, 0.0483, 0.0919, and that gives us this value right here we found, 0.1402, and then you take it away from 1. Matter of fact, I'll even put that in there. Equals 1 minus 0.1402, which gives us a grand total of 0.8598. Done with that one. All right, I don't have enough time to do the last problem, but that's all we'll do in the next video. So I'll see you then.